All right. So we're going to do composition of functions or combination of functions. And then we are also going to, you can put those over there. We're also going to move on to inverse functions. So change it to 1.5 because this, I just changed that. Yeah. Good. Okay. Combination of functions, the objection. What is the objective of this particular lesson? Hannah, go.
In this lesson, you are to find arithmetic combinations and compositions of functions.
Okay, good. So arithmetic is a funny little word. Arithmetic is also the same word, so you're not wrong saying arithmetic. But I use the word arithmetic. I don't know why. Anyway, rolls off the tongue better. So, arithmetic combinations of functions. Let's have a nice loud reader. Birthday girl. Go ahead.
Two functions can be combined by the operations of addition, subtraction, multiplication, and division to create new functions.
Yay! So we make new functions by adding two of them together. What about the domain? Trinity?
The domain of an arithmetic combination of functions f and g consists of all real numbers that are common to the domains of f and g. In the case of the quotient f of x divided by g of x, there is the further restriction that g of x will not equal 0.
Cool. All right. So we have restrictions that are going to happen to g of x. There are restrictions that may happen to f of x. And there are restrictions that may happen to the composition of those two, putting those two together, okay? For instance, f of x divided by g of x. So Puto says what I just said. What? Follow he who restricts. Fudge. Doggone it. Follow thee. Cody Wiseacre. All right. Follow the restrictions of f of x, g of x, and their combination. So we are going to do that. All right. So let's do that. Let's take each one of these and we're going to add them together. So when I have a combination of functions, it's showing the actual operation in between the names of the functions f and g. Okay? So for instance, f plus g, that would be the same thing as f of x plus g of x. And if we have f minus g, that is f of x minus g of x. This third one, f times g or fg, that would be f of x times g of x. And then the last one, the division quotient, or the division is a quotient of f of x and g of x. Okay? So we're going to take these examples that we have here, and we're going to look at two things. What the combination of those two are, and just a lot. What the combination of those two are, and their domain. So you may have seen how to put these two together, but maybe you haven't talked about domain. All right. Yeah, I spilled a lot that time. Oh well. So, let's do this. These two are just simply added together. I'm tired of red. I want to go with green. So, adding them together is literally taking 2x and adding it to x squared for our example up there. Okay, now is this in a standard form? No. Do you know how standard form works for equations and polynomials? Highest exponent starts first. But also, the letter, the letter needs to be the lower, or the, what do you call it? The sooner letter in the alphabet. A to Z. Yeah, there you go. So it's A to Z, highest exponent to lowest exponent. Okay? So this one ends up being x squared plus 2x. So we talk about domain of this, and that's where things get a little bit tricky. Or do they? What would the domain of f of x be? Brianna?
I have a question on the addition.
Okay, but first, what would the domain, I was asking a question. What would the domain of f of x be? Just f of x by itself. Ben?
All real numbers?
That's right, it's a polynomial. All real numbers are polynomials. Polynomials have all real numbers that you can plug in. How about g of x? Besides Ben. Come on. Is it a polynomial? Everybody should nod. X squared is a polynomial. It's a very simple polynomial, but it is a polynomial. And polynomials have what domain? All real numbers, okay? Literally, it's like this. If you have a normal expression that you've normally seen throughout Algebra 1 and Algebra 2, it's probably a polynomial. It's just a first degree. This one's a first degree polynomial right here. This one's a second degree polynomial. Multiply those together, it's a third degree polynomial. Okay? So, the composition of those two, putting those two together with addition, I keep saying composition, but I should say combination of those two by adding, is that a polynomial? Get some confidence, folks. Yeah, it's a polynomial. And if it's a polynomial, if this is a polynomial, that's a polynomial, that's a polynomial. The domain for our new combination is all real numbers. Yes?
Do you have to put these squiggly brackets to say the set of all real numbers?
No, it's okay. Because that's set notation. All real numbers is shorthanded. Now, on the IB exam, if they ask for it, you should write it all out. I'm not sure if this notation is accepted. I have to look at that. Okay, but it should be. They should know what that means. Never mind. Anyway, so let's do the next one. Ooh, f of x minus g of x? Bollocks. Oh, go ahead. Yes. Now's a good time.
So you said it's about powers and alphabetical. So powers always override alphabetical with powers?
No, alphabet first, and then powers. So like if I had a, b, a squared, x squared, b squared, 5f squared. Put your phones away. How would you organize that? Well, the highest exponent with the very first letter. A squared. Say they're all plus. Okay? The next letter, well, that would be A. Now, AB is like, who comes first? Andrew or Anna? Well, you look at Anna, A-N-N. I'm Andrew, A-N-D. D comes before the N. Same thing here. Okay? However, if my name was A, and then I talk to AB, AB comes after A. So, then we have AB. And then the next letter would be B squared. And then we'd have 5F squared. And then X squared. Okay? It's a little side note. I mean, we'll talk about it more later, but... no. Does that make sense? Cool, next one. We have 2x minus x squared. Let's put it in order. Negative x squared plus 2x. The domain. Ooh. Maybe I'm making noises and I shouldn't. Maybe I'm making noises because I should. Kim, what's the domain? All real numbers. Thank you, Kim. You have to look at f of x, all real, g of x, all real, and then you look at the combination of those two. All real. That is a polynomial. Next one, multiplication. We're going to take these two and multiply them. There is a little bit of simplification that we have to do. 2x times x squared. That looks like that's going to be 2x to the third. Ooh, Tyler. What's the domain of all real numbers? Yeah. Not tricked by my sounds. Ooh, that's actually not that bad today. The coffee is what I'm talking about. Can't see it. Yeah. It's just, ever since I overflowed the coffee, it tastes like old coffee. Do you remember was that this class that I did this? Oh, golly, Jehoshaphat. But it was, ever since then, it got into the reservoir. And so I pour the water in, the water gets tainted. And then I drink it anyway. So if you guys are ever thinking about doing like a collective group present for my birthday that you all missed, go to Goodwill. No, don't go to Goodwill. That's really gross, actually. Go to the store. They're only like $20, but I just don't feel like it right now. So collected, like, that's what I want for my birthday. That you all missed February 7th.
Happy late birthday.
Yeah, I had class and you guys said nothing.
I said something. You had our class? Oh, we knew.
You guys didn't even know. It was a golden birthday too. 32. It's not. It could never be a golden birthday. Okay, next one. Sorry, digression. Anyway, let's divide them. We have 2x over x squared. Can we simplify this? Yeah. You can take out an x. That's 2 over x. Oh, what's the domain? Breezy. What's the domain of this one, Breezy? The domain is not just that. All real numbers. And x cannot equal 0. And you know what? I am so happy you said that because I always forget to address it. A lot of students will just write x cannot equal 0. Okay? What can x equal, though? Don't forget to state what x can equal and what it can equal. Okay? Because it seems like, yeah, well, it's pretty obvious. But you do need to, state it. If it was an interval notation, that would be from negative infinity to 0, union 0 to infinity. And all of these would be negative infinity to infinity. And beyond. So, oops, boxes. Okay, any questions about that? What did the cow go see at the theater? Yep, movie. So we're going to move on. Oh, I love jokes. All right, now this, it says, do this if we have time. Well, I'm going to talk about it. I'm not going to actually do it on a calculator, okay? But I want you to recognize these are all functions that you should do, you should know how to do, except one, okay? So, the first thing that you should know how to do is plug values into y equals. It's that little button in the top left-hand corner of your calculator. you type in L1, L1. You type in Y1 and you type in Y2. Okay, now what this does is it stores a function in Y1 and it stores a function in Y2. So wouldn't it be cool if I could take Y1 and add it to Y2? Or take Y1 and divide it by Y2? Or take Y1 and multiply it by Y2? Wouldn't that be cool? Cool, because it is cool and you can graph it. So let's go ahead and do that. Now how do we do that? Suppose I want to make a Y3 and that Y3 is Y1 plus Y2. Well, there's a button on your calculator called vars. Variables. Okay? So you go over to that function, you press it, it's where, you remember distribution was? Dist? It's that button, you just don't press second. Okay? You press just vars. And then go over on your little vars table, over to the second spot, where it says Y vars. Y vars are our Y variables that we've plugged in. And then you get a list when you press enter. And that list tells you those functions. And so what we're going to do is we're going to take those and we're going to plug them in to Y3. Now how do you do that? Well, you have to select Y3. I forgot to mention. Okay, so you'd have to go back to the Y equals, go down to Y3, press vars, go over to Y vars, hit functions, and then select Y1. It's kind of a long process, and the outcome of it really isn't that wonderful, but it works. So you're going to plug them in as Y1 plus Y2. And then after you plug them in as Y1 plus Y2, or you could do Y1 divided by Y2, or Y1 times Y2, or Y1 minus Y2, you can graph all three of those functions on a graph. Okay? And you could press zoom standard, will get you to that 10 by 10 window that looks like this. Okay? 10 by 10, 10 by 10. The upper U is our Y2. The line is our Y1, and then the lower parabola, the lower U shape, is Y3, the addition of those two. Pretty neat. Now what does this do for us? Nothing. Except if you press the table button, second table, this is really handy, you press the second table button, it will tell you not just one, but it will tell you both of the functions' answers at each. So you can press second table, and there it is. You can scroll over, and you can look at Y3 as well. It tells you your X's and what your Y values will be. All right? Pretty neat. So maybe you wanted to graph one of these, and you were trying to figure out what's some good numbers that I could use. Well, you could graph it on your graphing calculator and look at the table with the values and say, those ones look good. And use those. Algebraically. We're going to have to state the domain as well, but I would like you to think about each one of these. Okay? So graphically, yeah, you put them together, you get a new function, okay? But algebraically is the one that I'm going to be focusing on the most. Do I have one of these? Yeah, you do it on your own. Okay, cool. So I'll do this one as well. And then we'll move on to ones that you could do on your own. Don't forget to state the domain. Find f minus g. That is 2x plus 1 minus, do I just write x squared minus 1? Parentheses, x squared minus 1. Okay? Don't forget those parentheses with subtraction. We're taking all of F and all of G. Isn't that song called like All of Me? Oh, all of G. I love it. We're going to take all of G and we're going to plug it in. That's so weird. And then I'm going to reorganize it. We end up getting that distributed to each term. I'm going to put it in order as well. X squared plus 2x plus 2. I'm not asking you to find solutions. I'm not asking you to factor. All I'm asking you to do is to find the polynomial. So you can leave it as is, as long as you state the domain. Yes?
Would it matter if you switched it so the x squared would be positive and the others would be negative?
Yes, that would be wrong.
That'd be wrong.
You know, the only time you can do that is when there's an equal sign. When there's like, if it's like this, it's like f of x equals negative x squared plus 2x plus 2. If you want, I mean, you'd have to make the other side negative. So you're referencing when you set it equal to 0.
Yeah.
When you set it equal to 0, you can divide that out.
Okay.
So, good question though. Leave the negative in front. It's okay. Is this a polynomial? Alex, is this a polynomial? Folks, that was a head nod. So he knows that means all real numbers. He mouthed it. It's recording a video. They can't see you. Okay. All right. Anyway, cool. Next one. Let's add them together. Super simple here. This one we don't have to put parentheses because I'm not distributing, and we end up getting x squared plus 2x. That's it, because my 1's cancel out. The domain. Oh, the domain. Pretty tricky here. How about Becca? Thank you. She's sitting in the back, folks. So she said polynomial, all real numbers. Oh, I guess I wrote it. By the end of this, I will just talk to the computer. What's up? How you doing? You giving me looks. Okay, anyway. Oh, brother. Next one, multiply them together. We have 2x plus 1 times x squared minus 1. Oh, we have to do something else. We don't just combine terms now. We have to do this other thing. What is it called? Foil. There it is. Foil it first. We have 2x to the third outside minus 2x inside x squared. And last we have negative 1. I'm just going to go ahead and just rewrite it. 2x cubed plus x squared minus 2x minus 1. Ooh, the domain of that. What do you think, Trebin?
It's all real numbers. All real numbers.
Nailed it. All real numbers. And now, ladies and gentlemen, the last but definitely not least, f divided by g. This one's always the trickiest. We have 2x plus 1 on the top, x squared minus 1 on the bottom. Now we look to always cancel things out. Put your phones away. Goodness gracious. Seems like one row. Yeah, you're both texting. We want to factor this. That is 2x plus 1 on the top. And on the bottom, that is, x plus 1 and x minus 1 when you factor that. Does anything cancel out? No, Caitlin's right. Nothing nothing cancels out. You know that 2 there, gosh, if that 2 wasn't there, it would. And that would leave a 1 on the top. But it doesn't. So, that was all in vain. Or was it? What's the domain? Totally rhymed. That's all real numbers, but x cannot equal what 2 values, Trinity?
1 and negative 1.
Yeah, and we could say plus or minus 1. In interval notation, that would be negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. Yep,
Why can't it equal positive 1?
plug it in.
Oh, well, I cannot thought that negative.
Oh. Yeah, if you plug it in right here, you'll realize that it gets 0 on the bottom. 0 is not good. So it can't have a 0 on the bottom. Okay. Next one. Okay, so those all dealt with f of x and g of x and stuff like that. This is saying, hey, what about f minus g of 4? Well, there are 2 ways of doing this. Let's talk about method 1. Okay? Method 1, we're going to take these 2 and we're going to combine them first. We're going to find f minus g of x. F minus g of x, we just take them, 7x minus 5, and we're going to subtract 3 minus 2x. We should probably simplify that. That is 7x minus 5 minus 3 plus 2x. Combine the terms, put them in the right spot, we get 9x minus 8. Do you agree? Am I going too fast? No? Okay, good. If you're listening to this on the interweb, pause it if I'm going too fast. Good talk. All right, so now let's do f minus g of 4. What do I do? Molly, what do you think I do? No, we don't need to distribute. I think you mean times each of the variables by 4. You're like shooting at a barrel and you're just missing it by that much, just by a little tiny bit. This was previously what variable? It was previously x. So what we're going to do is we're going to take 4 and substitute it in for x. Okay? It looks funny, but this is like saying, let's say this right here, f minus g, turns into h of x. Okay? I'm asking you to find h of 4. Same thing. I know. Oh, I see. You were saying distribute it to each of those. Okay. Okay. Yeah. No. This is just saying what the combination of the functions are. It's still a function, and if it's better, we maybe want to rename the function as h of x. You see what I'm saying? So you don't get that confusion.
Are we still going to times it by 4 though?
No. This is saying g minus 8 or f minus g of 4. Okay? That's how it reads. It looks like they're being multiplied. I get that now. It looks like they're being multiplied, but instead, it's the name of the function now. This is the name. Okay? And so when there's an x in front, you don't have to distribute it. Okay? All I'm saying is you take that 4 and you plug it in here. Like that. Just like you would for f of 2. But now this function is called f minus g. That's the name of the function. And you do it you get 36 minus 8, which is 28. So what's good about this method? Well, you go ahead.
Saying it's simple.
It's simple?
Easy to do.
Easy to do? Good. Yeah, it's easy to do. That's very true. It's easy to do. Anything else that's kind of nice? Well, let's do the second method, and then we can compare those two. The second method says solve first. So we're going to do, and don't think this is distribution, but we are going to take f of 4, and we're going to subtract g of 4. Okay? So instead, we're going to take this f of 4, and we're going to go 7 times 4 minus 5. And we're going to figure out what g of 4 is. That's 3 minus 2 of 4. And then when we get to it, we're going to subtract those two. Okay? But we're going to leave them separate for now. So that is 28 minus 5. That is 23. Minus. And this one is, looks like 8 minus 3. That is negative 5. So 23 minus negative 5 is 28. What do you know? Same answer. So, Caleb, which one's simpler now?
Second one.
Bam. However, there are some benefits and some limitations to each of these. First limitation is speed. Which one is obviously faster? Method 2. Okay? Method 2 is way faster. You simplify and then you just add, you just solve them individually and then put the numbers together. Okay? By the operation that it's asking. However, suppose you did this right here and then a part of the question is, what's the domain? What would the domain be of the composition? Well, what would you have to do if I asked what's the domain? You'd have to put them together just like you did in method 1. So method 1, I move to say it's more comprehensive. You can see what the function is, and then you deal with that function. Method 2 is just quicker. Okay? It's just faster. But you don't see what the composition of that function is. Suppose I said, what's the slope of the composition of the function? Well, it's pretty obvious what the slope is over here. It's 9. Over here, I don't know. I have to go back and redo it. So if there's any extra questions about it, then that would be the reason for a limitation. So, what am I trying to say? Read the question carefully, and if you see anything extra, do it method 1. If you see things that just say, answer it, method 2 is okay. Well, there was a question.
I'm still confused on the f of 4 minus g of 4. Like, why you did that.
This? Well, f minus g of 4 is the same thing as f of 4 minus g of 4. Because the same thing happened before. It was x. So if this was f minus g of x, same thing happens. F of x minus g of x. It was on a previous slide. So whether x is x, or x is 4, or x is a, or x is b, that's what we end up plugging in here. Okay? All right, let's have you do one on your own. This one's a fun one because there's a lot of domain restrictions. Good luck! And if you're watching this, you can go ahead and pause it because I'm going to sit here for a couple minutes. Or fast forward, I mean. Fast forward. Because they're going to work on it. Oh, I know. So here's what I'll do. I'm going to work on it, and I'm going to pause the screen so they can't see it. But I'm not going to talk while I do it. Raise your hand if you need a little more time. Do people just have hand raising problems? Raise your hand if you need just a little more time, like so I can see it. Thank you. I knew there was people out there. Where are you stuck?
R.
Just combining them, or are you stuck with the domain?
I don't know how to combine it.
Yeah, and then
Multiplying a fraction by basically a whole number?
Why do you have B and R? Like, why is it not B, C?
That was a joke last time. So it used to be ABA, and someone was like, "It's A, Mr. Zabuto." I'm like, "Oh, I'll change it." Change it to R. So when we multiply 1 over x by the square root of x minus 1, we just put them together as we would normally. Okay? If you take a fraction and multiply it by a whole number, what do? That's basically what it is. If I have 1/2 times 5, doesn't it turn into 5 over 2? Same thing here. If we have square root of x minus 1 multiplied by 1 over x, you just put it on the top. And then you look at the domain. They don't look that simple. When they're simplified, they don't look that simple. Okay? And technically, the bottom one I did wrong. I have to do one other thing. But we'll do that in a moment. Ooh, I actually explained it wrong in the last class. So this is not the final solution. Sorry, folks. It is actually... I'm talking to myself, don't worry. Say what? Mm-hmm. That should be the final answer. You have to rationalize the denominator. Okay. So, number 1. Before I show you all the answers, number 1, what'd you get? Be ready to be called on, and not your cell phone. Good night. Okay, Cody, I haven't talked to you. Cody, what'd you get for number 1? Adding them together? Oh, you did just get back from the bathroom. Caleb.
I had 1 over x plus x plus 1, so I forgot what it's
Radical symbol, square root.
called.
Yeah. What's the domain of that? Does anybody want to volunteer the domain? That was a denied hiccup. Kim, what's the domain?
All real numbers except for 0 and negative.
Except for 0 and negative. That's most of it, but there's still an infinite amount that you're missing. It's just a smaller infinite. Can I plug in positive 1/2? No. Can I plug in a positive 9/10?
X cannot equal 0, negatives, or fractions.
Or fractions? No. You're close though. Fractions less than fractions less than 1. So really your domain is
Write that.
well your domain is from 1 to infinity. Okay? Because it's redundant to say that it can't be less than 1 and it can't equal 0 because that's the same stuff. That's like saying I'm going to give you I'm going to eat donuts. And then I also state I'm going to have a maple bar. It's redundant. It's like that's a donut. Whoa, shoot. That's a donut. Okay? That's a donut. Spilled my coffee. Not a big spill though. I've done worse. So it's redundant to state things twice. So your domain would be from 1, including 1, to infinity. Did that go in? Okay. It's my new cologne called Kirkland Columbia. Molly.
Why can't it be negative?
Fraction or underneath the radical
Oh,
cannot be negative.
I was looking at the front.
So, Kim, how do we figure that out? Is there an algebraic way to figure that out? There is. You take what's underneath the radical and you set it greater than or equal to 0. Because that whole expression under the radical needs to be greater than or equal to 0. So that's kind of like the shortcut of doing that. So it's not only it can't equal 0, but it can't equal anything less than 1. So we don't need to state both of them because they're both combined. Okay? I'm going to go back. I'm going to just erase the bottom one. Whisper, whisper, I can hear you. I heard, he said, and then she said, just ask him. What was it? What?
You said to set it greater than or equal to 0, but then you said that it can't equal 0.
Okay, so here's what I'm talking about here. You're gonna see. Let's talk about B real quick. Multiply them together like this. Okay? Combine them, you get square root of x minus 1 over x. Okay? Now, how do you find that? Well, the square root of x minus 1, we're saying everything on the inside cannot equal 0. And so what we want as our solutions is that x minus 1, we want that to be greater than or equal to 0. And so we solve it, and we say, now x is greater than or equal to 1 because I'm adding 1 over. That's part of my restriction. The other part is that x couldn't equal 0, but this includes that. X cannot equal 0 in here. If I plug in 0 here, I get a negative number. It fails. So 0 is like a double fail. Doesn't matter, but it's a double fail. Okay? This domain right here, has anything changed with the domain from here to there? Same domain. So we end up getting 1 to infinity, including 1. Now the bottom one. Ben.
I have a question on the combination of number 8.
Yeah?
Would it be improper to convert the second bit radical x minus 1 over 1 to the same denominator of the first one such that they're like in the same fraction? So you have 1 plus x times radical x minus 1 all over x?
That would be more unsimplified.
Alright.
Because my natural tendency would be to take that x and to simplify that x right here.
Alright.
Yeah, it's a good thought. I must admit, to have the same denominator, but actually I would argue that what I've put is actually an easier function. Okay. Last one. Divide these two. What do we end up getting as our solution, or something close to the solution? Let's go with Caitlin on this one. I haven't talked to you in a while. What? Didn't get down to this one. Let's go with Malia. What did you get for this one?
1x over the square root of x minus 1.
You say 1x or 1 over x?
1 over
1 over x. Okay, so that's the first step. That's great. Okay, but we can't have fractions within a fraction. That's our first rule. Can't have double fractions. So how do we simplify this fraction? So you all know that if you take a fraction like 1 over 4 and divide it by 2, if there was a fraction divided by a fraction, like 2 over 1, then we would flip and multiply. We would flip the bottom and multiply. Remember that? When you divide it, that is actually just taking that 4 and multiplying it by 2. So that should be 8. Okay? Did we know that? You probably did, but maybe it was like in like 1999 or something like that. You know? I mean 2007. A while ago. It was a while ago. Okay? The other way, like what Ayana said, because she said such a good 8th grade teacher who taught her this, you take the bottom, you flip it, and you multiply it. Okay? That's 1 over 4 times 1 over 2, which is 1 over 8. Same thing. Flip and multiply on the bottom. Okay? So for this one, we could put this over 1, flip it, and multiply it, or we can just take this and multiply it by the bottom. We end up getting 1 over x square root of x minus 1. Now, I was pretty convinced that that was done, but that's not done. There's this thing that you learned a long time ago called rationalizing the denominator. Do you remember this? Uh-oh. Uh-oh. 1 over the square root of 2. Is that allowed? No, you multiply it by the top and the bottom to rationalize it. Square root 2 over 2. We have to do the same thing with x minus 1. So, we're going to multiply the bottom by the square root of x minus 1 and the top by the square root of x minus 1. What does that do? That creates the square root of x minus 1 times the square root of x minus 1. That's the square root of x minus 1 squared. So it goes away. We then get the square root of x minus 1 over x in parentheses x minus 1. And we can now finish by saying this is the square root of x minus 1 over x squared minus x. Okay? And this would be the simplified form of that. Let's talk about the domain. The domain. First things first, we have to look at the domain of the two original functions. The two original functions, we've already figured out the domain was between 1 and infinity, including 1. Okay? Now what I'd like to do is go back down and look to see if there's anything else that was added to this. Okay? Probably let's look right here. Or we could look right here. Or there are two junctions that we should probably look at. Okay? At any point, if we plug something in and it doesn't work, then it doesn't work at all. So I look at this and I say, we have two stipulations usually. One of them is fractions and one of them is square roots. And so the square root one we've already dealt with. It's up here. It's x minus 1. So we have to have numbers greater than or equal to 1. Now on the bottom here we have 0 for the x. But what about this side? What number would make this 0? 1. So on top of everything that we have, from 1 to infinity, we are not allowed to use the number 1. So our new domain is from 1 to infinity, not including it. Got that, Sarah? Good. See you to put numbers in your calculator. That's really cool. Okay. Oh boy. We're not even to the composition of functions. We just did combinations. But let's talk about compositions. Okay, so this one is a little confusing, but I think you've seen it before. A lot of you have seen fog before, right? Yeah? Calculator? Cool. Whose is this?
That's mine.
Sweetie.
You say that to me as
Oh. I was gonna say. I think I have another one for you. Oh, there's my belt. Anyway, I think actually I stuck it to something, so I guess you can't have it. But I just got a new polyvinyl record. It's a band called Zuzu. Good stuff. Anyway, so the composition of a function, let's say f and g, is to take it's to take the expression the function equals and to insert it in for x, okay, of the other function. Okay, so f of g, that's what that little symbol there is. F of g of x is the same thing as stating f in parentheses g of x. So we're going to state that whatever g of x is, we're going to plug it in for the x of f. Okay? So, you can't do it on the board. We'll look at an example in a moment. Okay? But we take the entire expression and plug it in for x of the other expression. Okay? So, the same domain as we've done before, it's the original domains, and then it's also the combination of the domains. Okay? It's the domain of f of g, the domain of f, and the domain of g. Okay? We use g of x as the x value for f of x. That's what we do. Okay? This is the formal definition. Let's look at an example. Okay? We're going to look at f of g, and we're going to look at g of f. And we're going to identify their domain. So the first one that I want to do is f of g of x. Remember, that is the same thing as taking f and plugging in g of x into its x values. Okay? So what does that look like? Well, it's basically, here is f of x, right here. 3x plus 4. And we're going to take the entire g value and plug it in for its x. That's all we're doing. That's what it means to take g of x and plug it in for x. So what I want to do, I'll make it a different color. 2x squared minus 1 there we go. See what I did there? Just plug the whole thing in. I plugged in the entire expression. Okay? That's it. Well, no, you got to simplify it, but that's what you're trying to do. 3 times 2 is 6. 3 times 1 is negative, 3 times negative 1 is negative 3. And so we end up getting 6x squared plus 1. Okay, and that is f of g of x. What's the domain? Taylor, I haven't talked to you.
I'm not sure. I don't know.
What is the function? Is it a fraction?
No, it's a polynomial.
And
So all real numbers.
all real numbers. There we go. Polynomials have all real numbers as the domain. You're allowed to plug in anything. Okay, let's do g of f. Oops. G of f of x. That is equal to g of f of x. Okay? And now we're going to do the same thing, but we're going to take f of x. We'll make this blue. we're going to take f of x. That's not blue. We're going to take f of x and we're going to plug it in for x on the other one. So this one we have 2 in parentheses, 3x plus 4 squared minus 1. Okay? This one has a little bit more to do. We're going to have to do I distribute that square to each of those? A lot of you are going to be tempted to do that. Do not do that. This right here is 3x plus 4 times itself, 3x plus 4. Don't forget that, okay? Don't try to distribute that squared value. It's like one of those little nuisances that stays with students. Don't do that. Some of us might know that this is a squared plus 2ab plus b squared. That's that perfect square of a binomial. So I know that this is going to be 9x squared plus 4 times 3 times 2, 24. X, 4 squared is 16. And then I distribute that 2. It's probably really loud. That's 18x squared plus 48x plus 32 minus 1. Gosh, I could just go 31. And that's it. Bob's your uncle. The domain. What do you think? I'll say it at once. Oh, that was really good. Not really. Man, if you were in that competition, let's do freshmen, let's hear freshmen. Yay, yay. Let's hear sophomores. Yay, yay. Let's hear Mr. Saputo's junior/senior class of IB pre-calculus. Sophomore. Nope, you have to go to the sophomore group. I'm just joking. I didn't mean that to be okay. Let's move on. Do it on your own. Oh no, that's not the one you do on your own. This one is. Okay, so I'll do this one with you. Here we go. Let's golf. Here we go. We're gonna take, and it's always nice to write. I like to do that every single time. It makes sense. Okay. So I'm gonna take this and I'm gonna plug it in. I'm gonna take f of x and plug it into g of x. Okay. So that equals. This one's a good little problem here. The square root of. I'm gonna make this red again. X squared plus 2x. I really don't need that actually. Parentheses. I can just plug it right in. Plus 1. Are we done? No, we are not done. What are we missing here? Yeah? Yeah, you can factor. What does that factor into? And then x plus 1. Wait, x plus 1 times itself? That's x plus 1 squared. So what is your answer? It's just x plus 1. Dunzo. Whoa, that's it, huh? Wow. Sweet business. Well, we still have to state the domain. Now, the domain's restrictions are pretty restricted here. What is our restriction? You would love to say all reals because the ending is all real numbers, but it all starts in the beginning with that square root. That square root tells me that this function reduces all the way down if x is greater than what value? Too many blank stares. 1 greater than almost. Guys, take x plus 1, set it greater than or equal to 0. That's how you do it. You take what's on the inside, set it greater than or equal to 0. So x is greater than or equal to -1. -1. Okay? So it's from -1 to infinity. That's our domain. So basically when I start the second one, I already know that my domain is from -1 to infinity until we get to the very end. All right, so let's take this and plug it in for x here and here. Okay? Because we're going to do f of g of x. We're going to take g of x and plug it in for the x value of f. So that is going to be the square root of x plus 1 squared plus 2 times the square root of x plus 1. So we simplify it. We get, square root of a square goes away. X plus 1 plus 2 square root x plus 1. Do we distribute that 2 inside of a square root? Not allowed. You could distribute a 4 into it, but that would de-simplify it. Do you know what I'm saying? Okay. So now how would you write this particular one? Technically you would write it as x plus 2 square root x plus 1 plus 1. That would be the, if you wrote it the version above, no big deal. And so our domain didn't change from -1 to infinity. You got it? Yes.
For the top equation, why can it only be -1?
What?
Why can't it be like -2 or...
Plug in -2 right in the beginning. And that's where you see that it falters. Okay? Yeah, it has to follow the 2 domains here as well as domains throughout. Do it on your own. How much time we got? Wow, okay. Well, we're not going to get to inverse functions. That's too bad. I talk too much. You're supposed to say, oh, no, you don't. Okay. Oh, I'm wiping off coffee. Sorry. Let's go back. There we go. Did you do both of them? There's two of them. You can find the domain of the top one, please, or the f of g. The bottom one, you don't necessarily need to find the domain.
You can't get rid of those.
Okay. You guys ready to check your work? The bottom one, the g of f of x, or sorry, the g of f of 2, I think I'm going to actually go over that with you. But the top one you should be able to get on your own. I keep saying top, but f of g. Let's just call on somebody. Molly, what'd you get?
I think you got 9.
9.
I don't know.
Close. I see how you got 9. But you made a little error there, but that's okay. Anybody else got a solution that's a little different? Should have an x in it. Brianna?
4x squared plus 12. Or minus 12.
4x squared minus 12. I see how you got that too. You're very close. Very, very, very close. Anybody else? Breezy?
I did 3x squared minus 6x squared.
Super close. You have one other tiny little thing that you need to do and it would be completely simplified. You are on your way to simplify it. Yeah? Cody?
Just minus 2 instead of minus 6. 3x squared minus 2 over.
Close. Here's what we get. Okay? Well, what you guys were saying is that I got this far and or pretty close to that, and I got a little screwed up after that. So what I did here after I got to this point is I divided each of them by 2x squared. 2x squared divides 3x squared, or sorry, 6x squared 3 times. And it's even. Okay? So the step that I didn't show was 6x squared over 2x squared minus 12 over 2x squared. And that's how I got this. Okay? So what did I do? I just took this value, I plugged it into the top, and I plugged it into the bottom. I simplified it. I distributed the 3, and then I reduced or simplified it. If you can get to this point, that's most of the points there. Okay? At that point here, you can kind of see what the domain is. That's good. Okay? This is truly simplified. If you want full marks, say it was out of 4 points, you would get a point off if you didn't get to this point right here. Okay? And then, of course, there's the domain. The domain says that I'm not allowed to equal 0, and I'm not allowed to equal -4. Farts. -4. I did that backwards. -4, -4, 0, 0. Sorry about that. Okay? That's my domain. Anybody get a solution for the second one? Golf. Breezy? -2 is correct. I'll put it right here in this little bubble. Okay? How did she get -2? Well, there's an easy way to do this particular problem. Like there was with the other problems that have to do with combination. We could do it way number 1, where we do the combination, we put the equations together, and then we do 4. This one is a lot easier to do f of 2 first. what is f of 2? F of 2 is 6 divided by 6, which is 1. Now, it's saying f of 2 equals 1. Well, that means that we have to do g of 1. What is g of 1? That's negative 2. Yeah. Okay, so I'm going to take that 2 and I'm going to plug it into the top here. 3 times 2 over 2 plus 4. That is 6 divided by 6, which is 1. And where did I get negative 2? I took 2, I plugged in 1, and I got 2 minus 4 equals negative 2. Yeah?
For the first one, I don't understand why negative 4 doesn't work.
Because it has to work with the original function.
Alright.
That's the reason. Okay? So, if you remember, it has to work with f of x, your numbers have to work with g of x, and your numbers have to work with the composition of those two. Okay. Let's see, example. Oh, this is going backwards. Okay, so this is a good question. It's asking you to identify the two functions. We don't have to work with the domain on this particular one. It is a pretty complex domain, but let's look at this. So we have h of x equals x plus 1 squared minus x minus 1. Find two functions, f and g, such that h of x is a composition of two functions. Okay? So what are we doing here? We have to recognize a function that has been plugged into another function. Find f of g of x. And the best thing you could do is to start with the inside. What did I plug in to get to where I am right there? Okay? This is obviously simplified for you to recognize, or not simplified, so you can recognize where that function is. Do you see that function that I've probably plugged in? Do you understand what I'm saying? I've taken a function and I've plugged it in. Now I'm trying to look at that and extract it. What is g of x? Tyler's whispering and it's x plus 1. Okay? How do we know it's x plus 1? Look, it's right there. It tells you. So if I plugged in x plus 1 into an equation, how did I get x? How did I get this? Well, h of x can be rewritten as x plus 1 squared minus x plus 1. So even more obvious, we see, hey, I have plugged in x plus 1, therefore g of x is x plus 1. What is f of x? X squared minus x. Someone said it over there. Okay? So look what I did. I took this value, and if I plug it into this function, I get h of x. So we have to go both ways. Not only do we have to plug it in and figure it out, but we have to extract it.
How did you find an x squared minus x?
Look at this right here, and notice that if I was to replace x plus 1 with g of x, I would get h of x equals g of x, you don't have to do this, squared, right? Minus g of x. So if I'm trying to figure out what h of x is, if I have f of g of x right here, because it says f of g, that means we have to figure out what my function was before I plugged in g of x. Because g of x, we've plugged it in for what? We've plugged it in for x, right? So I'm replacing f of x, or sorry, g of x, with just good old-fashioned x. And what does that equal? That's x squared minus x. Okay? It's pretty complicated, but it works. So this one down here, it says you try, but I'm not going to make you try it. it says we need to find f of g of x. Does anybody recognize what g of x is? X plus 3. So if g of x is x plus 3, what is f of x? X over x squared plus 2. Okay? Because I've plugged in g of x here, and I've plugged it in here.
Y on X cubed.
Oh, it's cubed. Excuse me. Thank you. Okay? Bummer. Well, I'm going to give you some word problems, and those word problems are going to have to do with a composition, or they're going to have to do with a combination using operations of functions. There are two that I had as examples. We didn't get to those, but these two examples are right here. Okay? Which some of you may recognize when I posted the notes that these are, I wrote challenging. They're really not that challenging. They're only challenging because they have words instead of numbers. So